Welcome back. Another video. As usual, we're gonna kind of dig deeper into things we have been talking so far. And this time I want to kind of touch up on something that's I think is extremely important when you start out to anything to understand, which is developing correct enzymatic pathways for success in health, fitness, or in anything, to be honest. Like, what the hell is happening there? So understanding enzymes probably would be a great thing. What the hell is enzyme? Uh, how do they function? And their role in human development, because that's what we're looking into the most. And
Yeah.
I think I can
So
even tie it down to almost that it's almost like a line of assemblies that everyone needs to put in place first before producing something. We are trying to
yes,
produce health, fitness, so that crazy word longevity, which is I don't know if I would achieve something like that, but we can definitely achieve higher quality of life for longer. That's for sure. So
yes.
would be
So
great to
so
see
it's
your
it's it's
insights.
very important to understand that life is a zero-sum game, right? What does that mean? That means nobody's getting out alive, right? Like that's okay. That's
Great start.
yeah, yeah. But see, the determination of when you exit has to do with energy, right? Like zero sum means energy cannot be made from nothing, and it cannot be destroyed. It can only be transformed, right? And so the more energy it's costing you to keep your system running, right? Your, let's just call it your household, right? The more energy it costs you to keep your household running means that you have a very high demand. The higher that goes, right, the more energy it costs you. You need to be making way more income. The problem is, as we age, that income gets diminished. But see, we have a unique capability of making enzymes. Enzymes do this right here on this slide that I have shown. It says,
Before you even go there, I know we have talked about it in our protein video. Just in briefly, in one sentence, just explain what the hell is enzyme.
yeah, an enzyme is it's basically almost like a peptide, right? It's a combination of amino acids that form some kind of a structure that does a couple things. And one of the things is what I'm about to explain is that it gathers energy for enzymatic actions. A lot of people have heard that word, enzymatic actions, right? What does that mean? It means that when there's an enzyme present in a specific chemical reaction or photonic reaction, it can be any reaction, right? When there's a specific enzyme related to that reaction that gets upregulated, that reaction costs you less energy to execute, right? So that's what this little slide is telling you right here. See, it has an arrow that says activation energy. Activation energy means it's going to cost you more energy to get to the top to make this to reaction coordinate, right? Because reactions are not random. See, that's a lot of another misconception is that people think that, oh, there's all these enzymes and they're all doing reactions and it's kind of just happening, right? It's just happening. No. That would mean chaos. They are happening with timing, right? Everything's just like an assembly line. Proper timing of proper reactions happen and they coordinate. And if you can make a reaction require less energy, right? So right here, if we look at this, there's a red line right here. That's how much energy it costs when there's an enzyme in that system that's been upregulated. And when there is no enzyme, right, without an enzyme, it costs you much more energy to execute that same reaction. What that really means is that it's going to slow down what's happening with those enzymes. If you don't have the enzymes upregulated, then the system gets slowed down. And if you do have enzymes that are upregulated, the system gets sped up because it's costing less energy. So it becomes way more efficient. It's a way to make reactions more efficient or less efficient. And it's not good or bad. It is what it is in relationship to timing. The timing is what matters, right? If you don't have a lot of enzymes, your timing for things will be extended, right? And if you have a lot of enzymatic action, your timing for things will be shortened, right? So broad level strokes, let's talk about fat loss because a lot of people are going to be interested in that. If you have very little enzymatic action related to everything that happens with losing body fat, then your time horizon for things gets expanded. Meaning, if you wanted to lose 10 pounds, it's going to take you longer than somebody who has a lot of enzymatic action already built up. The beautiful thing about enzymes is to signal for them to happen is almost kind of a semi-passive deal, not completely passive, but for some enzymes, it is quite passive as long as you're in the right environment. And for other enzymes, it's very low activity. Very low activity produces an enzymatic demand. The trick is to do it consistently and frequently, right? Consistently and frequently to upregulate those systems, right? And so let's talk about an enzyme. Not a lot of people, well, maybe some people will know about it, but this is coming out of our school group. And so we'll go ahead and go here, right? So one of our members is asking the CYP450 for testosterone production in testicles, right? So he's asking, right? He's just wanting to get a better understanding, right? Is that it's not the frequency of these enzymes needed for activation, which is in this case, he is slightly wrong. And the reason why, and we'll get into the details of that, is the CPY stands for 450 nanometer light. That's its peak absorption, right? So if we go over here to let's see, let me just move this out of the way so it's not in, here we go. Right here. Okay. So the P450 enzyme comes in 5 different classes, right? So most of these enzymes are not one thing, right? Because they're doing several things throughout the body. And so when you understand that it's a little bit more complex than just the question he asked, is that the P450 is class 1, class 2, class 3, class 4, class 5. The difference there is in the iron molecule, whether it's present or not, and whether it's a type 3, type 4, or type 2. That really doesn't matter. That's complex. But what this enzyme gains from having slightly variations of it is that now it has an absorption spectra that starts low, right, in the UVA range, like 420, and then ends at the peak of 450, right? So that's why it's called 450, is because the peak absorption of that enzyme is at 450, but because there is different versions of it, it starts to absorb clear down here at the UVA range, right? And we have some evidence of that with the spin rate, right? And we're not going to get into the spin rate of atoms and those types of things. So that's a lot more complicated. All you have to know is that the P450s start absorbing down in the 390s and they peak up in the mid 400s, the 450 range, right? So what does that mean in terms of signaling this particular enzyme? It means that you can start signaling this enzyme, especially if you have poor enzymatic activity, meaning you're low on testosterone, that's specifically this question, right? Or you're low on sex hormones in general, especially men, then you can start signaling in the morning when UVA shows up. For most people in the Northern Hemisphere, in the summertime, that's going to be somewhere around 9 a.m. to 10 a.m. That's how early UVA light's going to show up. And then what it does is, as the day progresses into the middle of the day, you get the most amount of blue and green in the daylight. And that's also when UVB shows up. In the morning, you're basically isolated to most of this spectrum with none of these. None of these are in there yet. So in the morning, sunning your balls is not going to do much for that complex. But in the middle of the morning, you start to elicit right in here. UVA starts to show up, and then these will come in with it. So essentially, it's a timing mechanism, right? It's a timing mechanism of, hey, you can start upregulating this P450 enzyme right before cortisol is going to be not cortisol, sorry, cholesterol is going to be sulfated when UVB shows up at the middle of the day. So in other words, you're turning on all these enzymes in the middle of the day as the day goes on. Like just hypothetically, let's just say that you're outside, you're naked, right? Like we don't have anything else going on. When the UVA shows up, it starts activating the P450 enzyme, or complex, I should say, which is going to be, class 1, class 2. And as the day becomes stronger in UVA and stronger in blue, you start activating more and more and more of these enzymes. And then finally, when UVB shows up, boom, you start sulfating cholesterol into water soluble hormones like vitamin D, pregnenolone, and DHEA, and your body has upregulated its enzymatic system to capture all of that information and all of that sulfated cholesterol and turn it into useful things. What did we just describe there? We described the assembly of an assembly line. Your body can assemble anything, but it has to put the assembly together. The manufacturing facility, right? And so what is the manufacturing facility? Mostly enzymes. And those enzymes are coded for, a lot of them are coded for specific frequencies of light. And so that's how passively you can upregulate an enzymatic system, which is why sunning your balls at specific times of the day upregulates testosterone pretty much every time, unless you actually have damaged testicles. But
And I
reason,
know you have live examples of that, where you have successfully worked with clients like that. And
yes,
what you just described of like manufacturer, like the simplest I can explain is, imagine when Ford was assembling cars, and then he figured out it's much quicker to put car together when you have one person dealing with one specific task, and then train full factory of individuals that do one task only, but put them in a
yes.
line, so everything goes 10 times quicker. So that's what enzymes pretty much do. You train them to make your body more efficient, because every single part of the, let's say, metabolism, muscle building, fat loss, and whatnot, now is done correctly at a higher rate, right?
Yep, yep, and costing you less energy, right? So how does this delve into like longevity and things of that nature? Is because it's life is a zero-sum game. You've extended your possible life by making yourself as efficient as possible, right? When you are as efficient as possible, now you can, as you know, build as much, as much muscle as you're willing to try to put on, or as much fat loss as you feel like you want to push for, or in this case, just living really well and keeping cells from being faulty and not having very many, how would I say, mutated cells that can potentially turn into cancerous. So you're essentially augmenting your body's ability to take care of itself without costing it as much energy, right? And that's really what enzymes are, and that's why I bring this next slide up. Enzymes are an important component of cellular processes. They act as catalysts to facilitate atomic motions and speed up processes or slow them down if you reduce the enzymes. And they also help prevent DNA from being copied by deuterium in certain parts of the nuclear code. This is a little bit more in depth in terms of like how genes are regulated by enzymes, which are regulated by your environment, which is how the environment regulates your genes, which is what we've talked about before. This is one of the key crucial steps because it's a physical step. It's not a chemical step. It's if the enzymes aren't regulated or aren't doing their thing, then processes get slowed down. And when processes get slowed down, more deuterium will be added to the DNA, which then makes it harder to replicate DNA quickly and effectively without mistakes, right? So even to the point of creating more, stem cells turn into other cells, they need DNA processes for that. That process is an enzymatic action, right? So even enzymes are related to just living and replicating and restoring your cells of all kinds, right? Whether it's a skin cell, an eye cell, or a muscle cell, it's enzymes are assisting in the replication process of cells and mitochondria. And if you slow that down, the way it gets slowed down, it adds deuterium in here so that you can come up with more mutations, essentially. So the body has a unique way of keeping adaptation going. Is when processes are really slowed down, it's trying to find ways to mutate to find a workaround so things don't. It's always aspiring to be as efficient as possible. Essentially, that's what survival is, right? Be as efficient as possible at whatever is happening right now. And deuterium allows it. So when I talk about deuterium depletion and things of that nature, most people just associate the deuterium as bad. It's not. Deuterium is going to be added to things on purpose when things are too slow, so that it creates biophotons, right? So let's talk about that for a minute. Biophotons are light particles that are generated by the sun and then captured by various photoreceptor molecules like melanin, leptin, all these other hormones that capture light. And then those hormones release that back in, right? So here's a description of those things: melanopsin, neuropsin, all these opsins that we've talked about recently. They're capturing specific frequency of light to do things with them later when you sleep. They're releasing biophotons, and those biophotons are specific frequencies down here in the UV range. They're UVA, UVB, and UVC. That means that they have better signaling capabilities for neurotransmitters and things of that nature. So when things get slowed down, more deuterium allows your body to make more biophotons so that it can try to figure out how to work things around when you're sleeping. Now let's talk about
and this is something we have discussed in like the video we made when you were talking about stem cell treatment and whatnot. And
yes.
it's basically this is why when you are in high light environment, everything seems to be easier. You feel better, your digestion is better, you recover quicker, your sex drive is higher, and so on and so forth, right? Because the cost of being human being efficiently just goes down because sun upregulates every single enzyme that keeps us healthy and
Yeah, it's essentially that's what you're doing, right? So think of it this way, right? If we didn't have all of this complex enzymatic activity and all of these high-end evolutionary adaptations that we've collected over time, we would be more like a gorilla, where we have to spend 80% of our day just eating food to keep processes moving correctly because it costs us that much energy. With the invent, right, the advent of losing some hair, creating more semiconductors like melanin on your surfaces, you can now accelerate collection of these energies like photons, light, and the production of them internally. So then what you end up doing is creating a system that effectively upregulates all enzymatic activity. And if you upregulate all enzymatic activity, it costs you less to live, right? So that's a a concept that's not unique, right? If you're making money, you figured out a way to either make more money or cut your cost, ideally both, right? This is exactly the same thing, but instead of talking about money, we're talking about energy currency, living currency, which is photons and electrons and protons, right? It's costing you less of those to keep the system moving when you upregulate enzymatic activity.
and it's great analogy when you talk about like costs and whatnot. It's not about if you want to make more money, you're not working harder, you become more valuable. That's basically what it is. You become more efficient at what you can deliver for others because nobody can make any money if you don't help anyone. It's just not going to
Right,
happen.
right. Yeah, yeah. So
Same with body, right? If your enzymes are, if you're not trying to force in yourself into anything by just taking some drugs or whatnot. You are improving yourself over time, where your body becomes more efficient at doing stuff.
yeah,
And
and then to kind of dovetail into the drug talk, right? Drugs that change genetics, right? The drugs that change how your body is functioning are doing things at the enzymatic level. For example, steroids are going to elicit certain enzymes to be upregulated. So now you can create a more pro-anabolic environment inside of muscle tissue and things of that nature. They're working on enzymes, right? They're just signaling it slightly different. But here's the thing. If you're like taking a steroid, for example, everybody thinks that, oh, you take a steroid and immediately that day or that week, you're getting the results. And technically, the processes have been kicked off, but because it's dependent on enzymes, not just for dismantling the drug, but the drug itself is signaling for more enzymes, you're not really even going to get the full effect of what's going on until weeks later, sometimes months later. And in some research showing even up to 6 to 7 months later before you're getting full effect on some of the systems, because it takes that long to upregulate those enzymatic actions. So even with drugs, you're being delayed by your capability to produce the enzymes. So anything you can do to cost you less energy to do that is going to shorten that time frame, whether it's a drug that you're taking or whether it's an activity that you're doing, right? And that raise in efficiency is just like you described. You're becoming more valuable. Each net time, at each minute that you're spending up regulating those enzymes are giving you back way more than before, right? So yeah, that's a great point.
do you want to touch into like the most important pathways, enzymatic pathways for health and fitness as such? Like, is it glycolysis? Is it muscle protein synthesis? Because we know fitter, healthier, if you want to live longer, so to speak, it's pretty much all about how much lean muscle mass you have, right?
Yeah. For the most part, the research is showing that to a point, right? Like the only caveat that I would say to that is once you start going super physiological, right? Like if you keep,
Obviously there is correlation and too
yeah.
much.
So I just want to make that clear because we do have, I have clients that are on both sets of the spectrum, right? Completely natural, just looking for longevity, and completely not natural, looking for the best outcome they can with also running a supercharged engine, right? Let's just put it that way, right? So no matter how good you are at producing these enzymes, a Prius is always going to be more efficient than a dump truck, right? Like that's just what's going to happen. But that doesn't mean you can't improve the efficiency of that individual vehicle by doing some of these things, right? So there is some delineation there. Some nuance, I should say. So the most important pathways that you want to regulate and keep as efficient as possible, number one, at the very top of the list is efficiency of sleep. All the enzymes related to efficiency of sleep. And again, lifestyle plays a huge role in how far you can take this, but that's where, our basics come in, right? Which is, hey, getting lots of sunlight in the morning is going to upregulate certain enzymes that then later effectively make a seesaw effect. Whereas if you get the right light environment at night, you're going to augment sleep, right? And for the most part, it's, circumventing blue light and electromagnetic fields at night for most people, right? There's unique situations where that might not be enough. And then in the morning, getting as bright as sunlight as possible in the morning, and then possibly, depending on the season, some light in the middle of the day, right? But bright light and cold exposure in the morning, and then in the evening, less light and also cold exposure if it's the right season, and then circumventing electromagnetic fields and blue light. Those are going to keep circadian enzymes running appropriately. Now, let's talk about fitness and either fat loss or muscle building or even mental capabilities, right? So now things like there are unique supplements out there called nootropics, right? People out there understand that you can take nootropics and they enhance mental activities. This is exactly what nootropics are. They are catalyzing more enzymatic activity so that it costs you less energy for each time that you're doing something. Things like NuPept are going to accelerate neuronal synapses, and they're going to accelerate the ability to kind of stay in the flow zone and stuff like that. Taking them before a learning experience is a great way to learn something new. Could you make an improvement on that? Absolutely. You could do that by enhancing blood flow to the brain and also shortening mitochondrial the electron transport chain, shortening it up. You can do that several ways. So I'm just going to, I'm going to lay out a protocol, just generic, right? But this is a way that you could do it, right? Like, let's say you have, I don't know, an important phone call or something new that you're attending, like a seminar or something like that, right? And so what you do about 90 minutes before is you would induce a learning setup, meaning you would I would probably do some journaling, right? I would probably do some journaling because with a pencil, right? So that way you're inducing motor units, visual units, and then I would do something that most people don't do. I would write a paragraph or even just a statement of what you want to accomplish in this learning activity, and I would write it and read it back to yourself. Now you're engaging all five senses. You're engaging touch, you're engaging eyesight, and you're engaging hearing. Bonus on top, I would use some kind of a scent that helps you concentrate. My favorite is menthol, right? So I would use some menthol to engage that sense. I would write whatever I'm writing, and as I write, I would repeat it back. So now I'm engaging all five senses, and I'm prepping the body for learning. Because see, learning is not just you read and you assemble. Some people can do that. Other people have to physically do and learn. So you want to activate as many senses as possible because you're not quite sure how you're learning, right? In the moment. So you activate all five, and then after that, you would take your NuPept or some kind of a nootropic, and then I would initiate some kind of physical activity to increase blood flow. And it has to be just light, something that induces a lot of volition. So I wouldn't say like it needs to be, you don't need to get a sweat on. What you need to do is jump up heart rate as fast as possible without costing you much. A simple one is high jumps. Literally just jump as high as you can for like 10 seconds, right? And then repeat that every 30 seconds for about I don't know, 4 minutes total, right? It doesn't have to be very much. And then once that activity is done, you relax for a minute, and if it's a learning thing, it's going to be in your mind. I would probably do a brain freeze. You could do it two different ways. You could just put some ice, some cold water in your mouth and let it freeze the carotid artery at the back. Or you could use a spoon, a frozen spoon, and stimulate your vagus nerve on your eyes. What you're essentially trying to do is you're trying to bring cold blood to the brain. Cold blood upregulates neuronal efficiency. So now you're speeding up synapses, and you've created enzymes to fuel the learning experience to come. It didn't cost you very much.
You literally could describe what Tony Robbins does in all his events. Extremely cold environment, a lot of movement before starting to learn, some massages, and writing and kind of literally speaking it out. That's literally what he tells everyone to do all the time.
Yeah, that's a hack. That's a hack. That's a hack for learning well, right? Because and why does it work? Enzymes, right? Because you took the time to upregulate them before the activity. What did I just describe with the 450 enzyme? The activity that's going to happen is going to happen in the middle of the day, but the enzymes are set up to start gathering information and assembling the manufacturing process earlier than that, about 3 hours earlier, right? So that when it comes time to do the task, you're 100% ready as you're going to be, right? And instead of just being flooded with, hey, now you have to do this task and you don't actually have any of your equipment ready, right? That's the best way to describe it. So that's a really good hack for learning and really any performance activity. But let's say your activity isn't mental, right? Let's say your activity is physical. You're going to be getting ready to do a training session, right? So in that case, what you would want to do is you want to do the opposite, right? Because enzymes are going to essentially be doing the opposite of what's going on in an activity. Because the reason why they're doing that is because they're making that activity more efficient, right? And so things like a little bit of cold exposure right before an aerobic session will amplify the effects of that aerobic session for both aerobic activity, and most people are going to be doing some kind of aerobics for heart health and probably fat loss, right? So cold exposure before or during the aerobic session is extremely helpful at upregulating enzymes. And that's actually what I do every day in the winter. I go outside and do 20 minutes of cardiovascular work in the cold with as much skin exposed. What that does is it allows me to push harder because cold is upregulating mitochondrial efficiency, and the cold is dumping, or it's making my cells acutely more insulin sensitive. What does that mean? Blood sugar is going to be going down instead of up. Most people's blood sugar goes up when you do cardiovascular work on a treadmill in a gym. If you have some kind of a continuous blood glucose monitor, you would see that the glucose is going up. It's dumping glucose into the blood, and you're stimulating it more by blue light. If you do cold exposure and outside, what you're doing is the opposite. Glucose is coming down, you're using it up, you're not feeling the drain because the mitochondrial efficiency is going up because of the cold. And on top of that, you're still making activity happen. What does that mean? It's going to upregulate enzymes that shunt fatty acids out of the fat and into the bloodstream to use for energy. You can do this passively, right? So this is intentional, right? I'm doing this intentional every single morning. That's an intentional, I'm putting out effort there. Although it's low effort, it's still effort, and I'm getting a lot more out of it than I would have if I do it slightly different. There's a passive way to do this. You described this before we got on here, right? You can upregulate enzymatic activity to fuel your body through glucose and fats by appropriately not feeding yourself, right? What I mean by that is you don't want to just fast willy-nilly. Like some of these will work eventually, but you can dramatically accelerate the efficiency by implementing what I call a hybrid fasting protocol, which is essentially you don't eat in the middle of the day, right? You eat a big breakfast, lots of nutritious food. You become really active. You can either work out after that or whatever, right? Or you just go to work, right? You're just active during the day, and you don't eat for 8, 7, 12 hours, right? And then you eat again. What that's going to do is it's going to essentially start the day in a fasted state. You fuel it appropriately. Then you perform a lot of activity in a fasted state. That's going to raise enzymatic activity for performance. It's going to raise enzymatic activity for fueling that activity because it knows that it got fed. And then you eat before the day is over so that any hole that you dug gets refilled. So the body doesn't ever really have a need to store it, right? It's not upregulating enzymes to store things. It's upregulating enzymes to get rid of things in that concept.
I think it's important to plug it in that it's not gonna get adaptations within a day or even a week. It will take some time.
Yes, yes. All these enzymes, again, you can make enormous amounts of enzymes over time. But that's a key thing, right? If your enzymatic activity, right, is going through this process right here, right? The process of and I'll make this real quick, is if your enzymatic activity is starting at the bottom of this, right? At the bottom of this curve, it's saying that it's going to save you this much energy. Well, energy can't be created or destroyed, right? That's key concept number one. That means even to make all these enzymes, it's going to cost you at least this amount of energy once, right? And that's going to fuel the process of making all these enzymes. Once the enzymes are made, you put in all that energy. Now the enzymes are taking care of you and cutting the cost each time you do it, right? It's just like a business, right? You will not start a business with some money. Whether that money comes from you directly or you get it loaned to you, you are going to have to put in some level of energy to the degree that you're wanting to build that business, at least once, right? That is what's a crucial component that you're highlighting. When you're starting from zero, you're not an ex-athlete, you're not an ex-high performer, but you want to become one. You have to understand that there's going to be some capital that you got to invest in there. That capital is essentially two things: effort and time, right? You can reduce the time by more frequent and more consistent small bouts of enzymatic upregulation, or you can do it by more intensity. That has to do with, knowing some of these are governed by environment and things like that. And going, like you mentioned, hey, maybe you go to, if you're trying to just feel better and upregulate all mitochondrial efficiency, you can do that very fast in 1 week if you go somewhere where the intensity is really high, aka the equator, right? Now, some other activities like fat loss and things of that nature, you can induce that synthetically with like oxygen chambers and red light therapy devices, and then coupling that with a little bit of work. You can accelerate and cut the time down of building those enzymes, but that's where you have to know, kind of the ins and the outs of what we're talking about.
And this is a difference between somebody who can get in shape within 6 weeks or takes 6 months. If somebody has been, we've talked about it off cameras, that we have worked with people whom we interview and they're like, oh, I've been in track and field when I was a kid, but I stopped training at 16 and now I'm 40. You still have advantage over somebody who has never done anything and just starts at 40. And we see it all the time, that those people who have done something early in their lives, they change way quicker.
Yeah, it's because they have underlying systems to make those enzymes that had already been upregulated, right? The body doesn't really get rid of those very quickly because it understands the importance of enzyme activity, right? So it keeps kind of those structures to make enzymes in place. Yeah.
That's well and forgotten muscle memory. Like once you build that, it's easier for your body to recognize. I think I've read some studies that even if you are exposed to some kind of drug, your body can mimic it and create it itself even without taking it anymore.
I have seen some research on that. I don't know if that's to all drugs or just a certain class, but it's not surprising
because you can do, right?
Yeah, I mean, technically, that's kind of how drugs work, right? If a drug has no target in your body, then that drug doesn't work. But if the drug has a target in your body, most likely there is something that your body already makes that is doing that. And so, if you amplify that through drug mechanisms, you're amplifying some of those enzymes, and then your body will be more efficient at doing some of that as well. Yes, that's totally dovetailing exactly with the concept that we're just talking about.
And again, I think. Just to highlight it all, that every single thing is personalized. You need to understand where you're starting. You need to understand where you're going. and then in the middle plug all these things that you have been covering for last, what, 2.5 years now? We're talking about all these things.
Yeah, in January it'll be 3 years. Yeah.
Wow. So again, just understand, if you are trying to get somewhere A to B with Z, this is why it's so important to understand that whatever your friend does might not be good for you, because they might look the same, but they might not come from the same environment. The food is not the same, the stress exposure is not the same, physical exposure is not the same, and everything else on top of that, right?
Right. Yes.
So on that note, we're gonna wrap it up, David. Appreciate your time as usual, and we'll see you next video.
Awesome. Thank you.